students who might use it, and then maybe we'll think of it.
That's a good one.
Yeah, how to tweak it, and in terms of information from Becky, how we might get feedback from students, you know, in a formative way as we do this. Where do mixture problems, as they're called, so-called mixture problems, typically come up in the, it's usually high school, isn't it? High school algebra?
Systems.
Is it fresh, oh, is it first year?
Is it usually systems?
You know what, I just
Your
remember,
ratios,
I remember when we
I think.
took them out.
Yes.
Years ago.
Yes.
Because you just don't understand
Yes.
them.
But,
Yes.
I would think advanced algebra.
Tend to be an advanced
As I recall.
algebra topic, yeah. I remember myself as a kid learning them in my first year algebra course, and of course not getting them. And I think a lot of places have kind of skirted around them or moved them to a different location. But in thinking about our focus on modeling and practical math skills that we can relate to other areas, I think mixture problems are a pretty important area, particularly for chemistry. Now, before we jump into this, I have to tell you, I have a little problem with the word mixture problems, using the phrase mixture problems. I'm not really fond of, okay, today we're doing mixture problems, tomorrow we're doing train problems, the next day we're doing, you know, swimming against the tide problems, those sorts of things. Because what it tends to do is cause kids to kind of compartmentalize their knowledge. And you know, it just resonated with me from Jenny Winter's talk, this idea of looking at the underlying math problem structure and trying to identify it. So even though these are called mixture problems, and the videotape that we'll see from the teaching channel is about teaching mixture problems, that teacher does a great job, in my opinion, of connecting up the framework for the problem to some other problem frameworks that the students will recognize. And I thought, you know, we could add, if we wanted to, people in this group could certainly add to Jenny Winter's list of problem structures as we move into secondary, some basic structures that recur again and again. So, enough said. Anyway, I've given you each a little bag of, of goodies. Yes, they're yours. Don't eat yet, But,
I haven't even peeked yet.
I'm going to take us through the slides, and then I have for us a little handout that I'll give us at the end. Basically, the handout just sort of recaps what the slide says. So, let's see, I do need help on advancing my slides.
Arrow, key to the, on the keyboard, sorry.
On the keyboard.
Or do you want to use my presenter?
Spacebar?
I'm probably better, just spacebar. Ta-da.
That work too?
That works, thank you. I have two kinds of candy in my goodie bag. Hershey's Gold Kisses and Hershey's Silver Kisses. You can check that I can stuff the bags appropriately.
My Hershey Gold Kisses are gone.
Oh, no. I probably won't tell you yet that I have more. Imagine that I decide to eat, well, there are 10 pieces altogether, and 20% are gold kisses. Would you verify that? Just in the bag. Verify that you have 10 pieces altogether, and verify that you consider 20% to be the gold. We good so far? Imagine now that I decide to eat some of my silver kisses, and now 25% of the remaining pieces are gold. How many pieces of the silver candy did I eat? Okay, not too hard at this point for kids to figure out. Why do you think with mixture problems we might take the time to actually approach them like this? Or what could be learned from the idea that I ate some of the silver ones, and now my percentage has changed?
Makes it more beautiful. Like they can see it, they can visualize it, they eat food, candy,
Okay.
and count like how many totals do I have, how many would I need a quarter, okay, I need to bring some, play with it.
Would middle school school students be able to figure out how many of the pieces of candy were eaten in order to result in a 25%?
Yes.
Okay.
Without really doing any equations,
Yes.
just set up your 4 groups.
Yes, yeah,
That's kind of what I did.
yes.
I think I would have kids who would struggle a little bit, so I'm just curious.
What do you mean? What do you think would be
I think they
the?
will, but they can visualize and they would try,
So
right?
like,
The
let's say a
fraction.
kid who was completely clueless.
They would have to know 25% is 1/4, that if you
Yes.
don't know that, I mean, because I was
Okay.
going, if they knew
Okay.
25% was 1/4, you have 1/4 of them, so everybody else is silver, and then what's ever left. But if they don't know that, I'm not sure.
Okay, there is some underlying knowledge they're gonna have to be familiar with in order to do that. Is there anything there in asking that question, would any of your students be bothered by the fact that, among the gold kisses, it started out 20 and now it went to 25, and we didn't really add any gold pieces into the situation?
That'd be a good conversation.
Yes, yes.
Say that again.
Joe, you had a comment?
No, I think some of us probably some might core or lower students might, yeah, it's going up, but I'm taking my pieces.
Yeah.
You're decreasing
Oh,
the
good,
amount that you get.
good, a good question. Why does the percentage go up, even though we haven't even touched the gold?
This gets back to what Jenny's talking about, just the problem-solving structure. I don't think, most of my kids have really much clue at all about percentages.
Right, and you know, percentages, to report a certain percentage is independent of the actual quantities, isn't it? It's, you know.
It's an extra.
Yes, exactly. She was talking about that. It's an abstraction. It's numeric, and yet it's an abstraction because we can't really see anything changing, and yet the percentage has changed. Okay, I don't want to know this, but drive it crazy.
So if you
Oh.
were with the remedial class, you could tweak it to make it percents. I mean, to make it fractions. I'm just, if you really knew that
Yes.
that was gonna be a sticky.
Or I think you just have to scaffold
Or,
it a little,
yeah.
or have more practice, or just simple percents.
This particular problem I envision for maybe 7th or 8th grade, they have been exposed to
Right.
fractions. And they do have some fraction, percent, and decimal knowledge. But understanding percents, not in a concrete way, but in a relational way, is what's going on here. Now suppose I start out with my candy bag containing 10 Hershey Kisses. I don't make nearly as nice of slides, do I, as Becky does.
These are fine.
So I'm teasing, I'm just thinking.
I'll work with you.
Oh, I need work. Anybody who'll work with me is appreciated. I start out with my same setup, but this time I add 2 silver kisses to the bag. Be with me? Yeah.
I need mine
Oh,
too.
you-
I'm very visual.
I only have golds here. My husband ate the silver. Yeah.
Wait, you have a spare bag here,
Oh,
which should have
let's-
10, which
I have
should give
several
each of us
spare
2.
bags. Let's scavenge.
Okay, so send 2 down, 2 down.
I'll take it to gold.
You don't take the
Here,
other side.
Joe. A bag of your own.
Thank you.
Okay, does everyone?
Okay, I'm
You
gotcha.
too.
Here's the other 2.
And I have 2. Nice. Are we good?
Well, so the question now becomes for ourselves and for the kids, will this addition of 2 silver kisses to the bag increase or decrease the percentage of gold kisses?
Oh,
Yeah. It's the same sort of idea as the previous question, isn't it? Yeah. I don't even have to touch the number of gold pieces. I don't, to change the percentage in the bag. What percent, by the way, are gold pieces now? Anybody want to calculate?
It's 17, isn't it? 1/6, 2
Let's
12.
think about that. How would we figure the percentage of gold pieces now?
Oh, I'm sorry, I thought I
Count the
talked.
total, and then say I have this many out of this. and
Yes.
I'll write it as a fraction, and then.
2/12,
Yeah.
1/6, and then,
It's 16.6 now.
I think you're right, 16 and 2/3%.
Yeah.
So far, so good? I mean, for some kids, it is eye-opening to realize these percentages change, even though the little boys do not. Okay, will this addition increase, or, let's see, what is the percent of gold pieces now? Will the addition increase or decrease the percentage of silver pieces? It will increase the percentage of the silver pieces, won't we? We actually did put more in, and our ratio will go up. And then what is the percent of silver pieces now?
16,
Uh-huh.
84.
Uh-huh, yes, 83 and 1/3 or something.
Yeah.
Yeah,
Whatever.
we good? Okay, okay. Enough of that. Let's get to the meat of this now.
You're so creative. I was setting up a fraction in my head again. And you're just like, just subtract it from 100.
Here goes.
Okay.
Suppose 10 gallons of a 20% salt solution is left in an open container in the hot sun. How much water evaporated from the solution if after a few hours, the solution is found to be 25% salt? So thinking about this, if it started out 20% salt, and then after a few hours, it was 25% salt, did we add more salt? No. What did happen? We took some water out, some water evaporated there, yes.
That flows
better than
so
Hines
nicely with the
together.
Hershey's.
Now, maybe you can see now why I wanted us to start with concrete, discrete, actually countable materials. You with me? Follow what I'm saying? What I specifically wanted to ask you about, and what occurs to me is, when I used to teach this, I had students who really weren't sure what it meant to say you had a 20% salt solution. Have you had that
Definitely.
experience?
Yes,
I
that's
don't
the
know if it
biggest
means,
problem.
2 parts salt to 8 parts water, or 2 parts salt to 10 parts water. You know what I'm saying?
They just kind of think of it as a salty solution.
Yes.
Without
Yes.
really, yeah.
Yes, yeah, they don't know if the comparison is part to part or part to whole, even though we know darn well, we taught them what percent means. In this context, a lot of times they struggle with that. So, okay, here goes.
Oh, this is good.
Suppose I start out with a mixed bag of gold and silver kisses, which is 20% gold kisses, and again, there are 10 pieces total. Suppose I add 2 silver. This is repetitive, isn't it? Will this, I'm sorry, I'm gonna advance one more. Suppose I have 10 gallons of a 20% salt solution, and I decide to add 2 gallons of water to it. Will the percent of salt increase or decrease?
Would be
20% salt, I decide to add 2 gallons of water. Maybe I better go back to that previous slide. No, okay.
No, it's your
Inverse
60.
proportional.
Mm-hmm. So what, in terms of, not numerically at this point, but just qualitatively, will the percent of salt increase or decrease? Yeah, if I'm adding.
Because you're diluting.
Yes, we're throwing more water in there. Well, we just don't have practical experiences, do we?
Exactly,
With solutions.
not with chemicals, not with water and salt.
By the way, that's what we're gonna see on.
This is much easier to get.
Yes, because we can see it putting together, we can see the
They're
parts,
mixed in
even
our
though we
bag,
mix them
yeah.
together, we can still see what went in there.
I wanna know the percentage if I eat one.
Find the percent of salt in the resulting solution, if you don't know. Yeah, same deal?
Yeah.
Okay. All right.
Isn't this more, I feel feel like maybe the reason why they choose it, some schools choose it, is because this seems more like chemistry questions.
It sure
And
does, doesn't it?
First year high school students, I mean, won't get biology.
Yeah.
And I don't know about earth science, like like now, moving to junior high.
Yes.
If they even touch,
Looking at
Stuff like
this,
this.
at this point, this is a challenging question, isn't it?
well, we can talk about like, well, making a cake, or making bread, or something like that, that might help.
So what I hear you say, Joe, is that this context is worrisome to you because your first year algebra students may not, if they aren't enrolled in chemistry,
Yeah.
they aren't gonna be able to handle this.
Well, and you
Just a different
chemistry, they don't
context.
show them a different context, maybe, oh, it's a math, I can do this.
In chemistry, they just do it,
separate everything,
and
yes.
without necessarily giving much of an explanation. So I'm gonna ask you to hang on with me for a minute, all of you, including you, Joe. I think you raise a legitimate question. No, not yet, not yet. But wait, just wait till you see how this teacher we're gonna look at categorizes this particular problem. So let's read through it and make sure we're okay with it. It's kind of a complex question and hard to keep track of. A chemist mixes 70% saline solution. Can you visualize that?
So the 3 and 7, three and
Yes.
7 we're talking about.
Yeah.
We're talking about 3 gold and 7
Seven,
silver.
yes.
Beryllium.
Yes. And with 8 liters of a 25% saline solution. Now let's think about a 25% saline solution is less concentrated,
Right.
isn't it? And it would make sense that if you mix together a 70% and a 25%, that you'd get something in between. She was creating a 40% saline solution. And the question is, how much of the 70% solution was added? That is a classic problem. Do you want to think about that a minute?
No, I wanna see how she teaches it.
I want you to take a minute and, well, answer the question that I have there, first of all. How is this problem similar to or different from what we've just been doing with our candy pieces in the bag?
I feel like this would be like the next step of a rich problem.
I didn't hear that.
This would be like the next step of a rich problem.
Yeah, this is headed towards a rich problem, and it is a little more, it's a next step sort of thing from what we were doing.
It's almost like we need 2 piles of the kisses with the chocolate, one for the 70% solution, one for the 25% solution,
I'm
so
afraid we need
that's.
more kisses.
Joe says we need more kisses.
You can tell that I'm.
What's different about this from the one we did? By the way, we'll get to that. We will get to it.
Just what she was saying, it's a little more complicated.
It's more complicated, there are more relationships. The idea that we now have to create a specific amount of this 40% solution.
I don't think I could do this in my head anymore. I think
No.
I have to start writing it down, like
Yes,
trying to figure out,
yes.
like, drawing the line.
So let me see if I can pull up this video I want to show you. And it's this one.